Day 615 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1458, max dot product of two subsequences. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given two arrays nums1 and nums2, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. A subsequence of an array is a new array which is formed from the original array by deleting some can be none of the characters without disturbing the relative positions of the remaining characters, i.e. an array of integers 2, 3, and 5 is a subsequence of an array of integers 1, 2, 3, 4, and 5, while 1, 5, 3 is not. All right, y'all. So now that we've read the question, let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get into these examples, I just want to show y'all what the dot product actually is and how that works. So all we're doing is, say we have this array right here and this array right here. All we're doing is we're going to take A1 and multiply it by B1. Then we're going to say plus or add to that A2 times B2. Boom. Then we're going to add to that A3 times B3, right? So it would look like this: A1 plus B1 plus A2 plus B2 plus A3 plus B3, right? So a better visual representation of that would be this array right here where we use real numbers. So it would just be 1 times 4, right? That's this right here, plus 3 times -1, that's this right here, plus -2 times 2. Boom, that's this right here. And this will right here will give us 4. Then this right here, we get the -3. Then this right here, we get the -4. And in total, it come out to -3. So that's how you get the dot product. I just wanted to show y'all that just in case you didn't know, because it's important to know when we get into these examples. So let's go ahead and take a look at example 1. In example 1, we have input nums1 equals an array of integers 2, 1, -2, and 5. Nums2 is an array of integers 3, 0, and -6. The output is 18. So how did they get 18? You may ask. The explanation tells us we're going to take subsequences 2 and -2. So this 2 and this -2, because remember, we can delete some characters. So all we're doing, we're deleting this 1, deleting this 5 until we're just left with this. Boom. Then we're going to take, that's from nums1. Then from nums2, this array, we're going to get the subsequence 3 and -6. So once again, we're just going to delete the 0. We're going to be left with this, right? An array of integers 3 and 6. Then we're going to find a dot product. So we're going to take this 2 times this 3 right here, right? Boom. And we're going to add it to this -2 times this -6. That's this right here. And when we do that, this gives us 6. This gives us 12. 6 plus 12 is 18. Thus, our output is 18. Now, just in case that didn't make sense to y'all, don't worry. We're going to get into example 2. So in example 2, we have our input nums equals an array of integers 3 and -2. And nums2 equals an array of integers 2, -6, and 7. This time the output is 21. So we're going to take subsequence 3. So all we're going to do is take this 3, right? Because we want the max dot product, right? So by knowing that we want the max, we already know if we take this -2, anything, if we multiply this 2 times -2, we're going to have a negative number. And we multiply this 7 by the -2, we'll have a negative number. Most we could do is multiply the -2 times this -6. That will get us 12, but we already know this 3 times 7 is 21, and 21 is greater than 12. And once again, we want the max. So we know we're going to take this subsequence 3 right here. Boom. Then from nums1, all we want is this 3. Boom. Then we're going to take subsequence 7 right here. Boom. So we're going to delete this 2 and this -6. All we want is this 7. Boom. And then when we do 3 times 7, that's going to give us 21. And our output is 21. Now, just in case that didn't make sense, y'all, let's take a look at example 3. Example 3, same principles apply. So in example 3, we have our input nums1 equals an array of integers -1, -1, and nums2 equals an array of integers 1 and 1. The output is -1 because what else could it be? It says we're going to take the subsequence -1, boom, because that's all we have over here. Then we're going to take the sub from nums1. Sorry, y'all, that's from nums1. Then from nums2, we're going to take the subsequence 1, right? That's all there is to choose from. So we're just going to take this 1. Thus, the dot product would be -1. It'd be just -1 times 1. That would be -1. So that's how we got the -1. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution's not that difficult at all. Let me just get rid of this. Boom. Now let's get into it. Now, the first thing we want to do is we want to ensure nums1 is the longer array to minimize the DP space usage. If nums2 is longer, we're going to swap them and compute the result. So we're going to say guard nums1.count is greater than or equal to nums2.count. Else, we're going to open up the brackets and we're going to say return max dot product, and we're going to pass in nums2 comma nums1. Boom. Then we are going to come right here and we're just going to initialize this with a initialize this constant with a small value to ensure that at least one pair is chosen, even if all the products are negative. So we could just say let lower bound equal 1 0 0 0 0 0 1. Boom. Why not? Yeah. Boom. Then we need to create our dynamic programming table to store the maximum dot product. So we come underneath this, declare a variable called prev dp. Sorry, y'all. We're going to set that equal to an array. Open up the parentheses, repeating, colon. It's going to be repeating lower bound, comma, count, colon, nums2 dot count. Boom, just like that. Count plus 1. Sorry, y'all. Boom. Now we're going to iterate over the elements of nums1 by saying for I in 1 dot 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 nums1. Sorry, y'all. That should be 1 dot count. Open up the brackets. Then we're going to declare a variable to represent the current dynamic programming row for index I. So we're going to declare a variable called dp. Set that equal to an array. Open up the parentheses. Repeating colon 0 comma count colon nums2 dot count plus 1. DP of 0 is going to be invalid because the dot product requires at least one pair. So we could come underneath this and say set DP square bracket 0. We could just set that equal to lower bound. Boom. Now we're going to iterate over the elements of nums2 by saying for j and 1 dot 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 nums2 dot count. Boom. And so we're going to say, then we'll come right here, declare constant and say let a equal max, open up the parenthesis. So we're either going to skip either nums1 I minus 1 or nums2 j minus 1 and take the best result from the previous row of the left cell. So we'll say let a equals max prev dp, square bracket j, comma, dp square bracket j minus 1. Boom. Then we're going to come underneath this and we're going to declare another constant and say let b equal max, open up the parentheses, and this is going to pair nums1 I minus 1 with nums2 j minus 1 and either extend a previous subsequence or start fresh from 0. So we're going to say let b equals max prev dp square bracket j minus 1, come outside of that, comma 0, come outside of that, we're going to say plus nums1 square bracket I minus 1, come outside of that, we're going to say times nums2 square bracket j minus 1. Then we're going to choose the better of the skipping or pairing by coming underneath this, and we're going to say dp square bracket j equals max, open up the parentheses, a comma b. Now we're going to move the current dp row to prev dp for the next iteration by coming right here, and we're just going to say prev dp. We're just going to set that equal to dp, and now the final answer is going to be the maximum dot product by coming right here, and we just have to say return prev dp square bracket nums2 dot count. Boom, y'all. That should be all she wrote. Let's give it a run. Make sure it runs correctly before we submit it. Okay, we got the wrong answer, y'all. So know what that means. That means somewhere the math ain't mathing. So let's see if we can figure out where our math went wrong. Okay, y'all, I think I see what the problem is. This right here should be a negative number. So let's run this back, see if that's what was causing it. I think that is what was causing it, though. And look at that, it's accepted, y'all, just like that. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 2 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.